Welcome back, folks. Today's episode is part 2 of a 2-part series. I released a couple of weeks ago, I released an interview with Dr. Bill Lawrence, who is the longevity expert and researcher who is currently in the midst of a trial using bioregulator peptides to see how they influence people's biological age versus their chronological age. And the way that they're measuring that age is by measuring their telomeres and also measuring DNA methylation using the Horvath DNA methylation clock. Now, in the first episode, we talked extensively about the telomere results, lengthening results, and that was pretty amazing. And today we're going to talk about the DNA methylation of results, which are also great, not quite as dramatic, but very meaningful as well, and definitely a step in the right direction. Now, we do spend some time at the beginning of this episode reviewing some of the background information from the first episode, but we don't talk about the results. So if you missed episode 1, I encourage you, and it doesn't have to be before this episode, but I encourage you to go back and listen to it. I believe it's episode number 42. The link will be in the show notes. Also, if you're listening to this on Google, Spotify, iTunes, you're going to also want to watch the video on YouTube, because we use slides quite a lot in this episode. So it may be that you don't have time to watch a video right now, so you might do a first pass just listening to it. And then when you have a little bit more time, maybe sit down and spend some time with the video, because there's great pictures, great graphs, all that kind of stuff. So that's it. Dr. Lawrence is, as I said, as we've said before, he's a longevity expert. He actually works for the St. Petersburg Institute of Gerontology and Bioregulation, and he refers to Dr. Vladimir Khavinson as his boss. So he's running these trials in collaboration with Dr. Khavinson, and what they are using as their bioregulator peptides are the oral Khavinson peptides. These are the oral animal-sourced bioregulator peptides. So this is all that they're using. They're not using injectables. They're not using the synthetic version. They're only using the oral version. So I know that a lot of people have been reaching out to me, asking me what they're using, and that's what they're using in this clinical trial. What else can I tell you? If you have any questions, if you have any comments, you can reach out to me. You can reach out to me through my website, which is natniddam.com. You can also find me on Instagram at Nathalie Niddam on Instagram, and also Clubhouse. I host a Clubhouse 30-minute room every Wednesday morning at 8:30 a.m. If anybody's interested in checking that out, although that is a group, it's not my group, but it's a group that focuses really on women 50 plus. So of course, bioregulator peptides are very relevant for that group. But if you're a guy listening to this, you might not get quite as much out of that room. How else can you connect with me? You can find me on Facebook in the Optimizing Superhuman Performance group. That's a group that you would have to ask to join. When you do, please give me your email. I know people don't like giving their emails, but I promise you I won't spam you. It's just that I have a lot brewing this summer. I've got a newsletter coming. I've got a couple of courses launching. So if you want to be up to date and apprised of those things that are coming first, then give me your email and you'll be on my email list. Okay. I promise you I won't spam you. I won't sell your email to anybody. I don't have time to spam. I barely have time to keep up with what I'm doing. The other place you can find me, if you're really not a Facebook person, you can find me on the Biohacking Superhuman Performance group on MeWe. That group is smaller. It's not quite as active. It's more of a backup group in case something happens to Facebook, but it's definitely there. There's some great people in there as well. It's just that I'm not able to be there as much because I'm just too busy with everything else that I'm doing. What else can I tell you? If you get value from this episode or any of the podcast episodes, please make sure to leave us a review, because that's what helps us to rise up the rankings and to get amazing guests for you guys. And also, if you get value from the episode, make sure that you share it with friends, family, your networks, anybody who you think would also get value. And I'm also going to invite you guys to another opportunity, which is if you come across an amazing product in the biohacking space, in the longevity, in the anti-aging space, then make sure to shoot me a note about it, because I'm always looking for new stuff, and I'm only one person. So some of my most amazing guests have come from suggestions from listeners just like you. So if there's anything out there that you think I should know about and that I should be covering, then shoot me a note and I'll see if I can make it happen. And finally, I do want to articulate the disclaimer that everything that's in this podcast is really for information purposes only, right? We're not diagnosing, we're not treating any disease. Whenever you listen to this stuff and it kind of blows your mind, you've got to talk to your doctor about it or find a practitioner you could work with on this stuff so that you can make sure that it's right for you. As magical as peptides and bioregulators may sound to everybody, and they really can be, there's always caveats. There's always going to be people that maybe aren't quite ready for them or they're not the right thing for them. So please don't take any of this information as anything more than information and an ability to upgrade your knowledge so that you can become your best health advocate with your practitioner. So thank you so much for being here. I appreciate you guys. I'm so grateful that you listened to the show. We are growing by leaps and bounds, and it's all thanks to you. Thanks again, and enjoy the episode. Hey folks, before we launch into the episode, we have a sponsor, and our sponsor today is drinkhrw.com. And this company is all about the magic of molecular hydrogen. They make the most incredible molecular hydrogen products. So they make these tablets that you can easily just drop into your glass of water every single morning as you start your day, which is exactly how I start my day. I start my day with 2 tablets of molecular hydrogen, this stuff, in water with a squeeze of lemon, and that's what I take my supplements with. And so why do I do that? I do this because molecular hydrogen is this amazing foundation supplement that I include in mine and pretty much every protocol that I write for my clients. And I got to tell you, there's not a lot of things that I include for everybody, because I do believe that everybody needs different stuff. Everybody has different needs. But when it comes to molecular hydrogen, when we talk about a supplement that can help to manage inflammation, reduce inflammation, it helps to reduce pain in many cases. It helps to balance blood sugar, right? So improve insulin sensitivity. And when you hit even just those 2 markers, we are talking about already upgrading your body's ability to function really well during the day. Also really good for energy, really good for recovery for athletes. It's a pretty amazing substance, especially when we think of the fact that molecular hydrogen as a molecule is the tiniest molecule. It's the first molecule on the periodic table, but it's because it's so tiny that it is able to get in where it needs to in the cell and initiate all of these incredible processes. Drink HRW also has tablets that you can drop into your bathtub so that you can soak your whole body in it, get the benefits for your skin, get the benefits systemically into your body. So your skin is your largest organ of absorption, guys. So this is a great way to get your molecular hydrogen. It's also really great for people who've got aches and pains and who are sore. It helps to mitigate all of that inflammation. So what are some of the other reasons why you might want to drink molecular hydrogen? Well, as travel is starting to come back, is making a comeback, then I drink molecular hydrogen on my flight. I start 30 minutes before the flight, and I take it every 90 minutes while I'm flying, because when we're way up in the sky like that, we are actually exposed to radiation, and molecular hydrogen has been shown to be helpful at mitigating the negative effects of that radiation on our bodies. So ultimately, supplementing with molecular hydrogen is all about aging well. It's about longevity, and it's about managing your body system so that you can look, feel, and perform your best. And this supplement, molecular hydrogen, delivers on these points like nothing else. And one of the things I forgot to mention is that molecular hydrogen actually combats oxidative stress. And it's not just anti-inflammatory, it's selective selective antioxidant. Plus, it also helps to support a healthy inflammatory response. So you guys, obviously, I can keep talking about this for a really long time. What I'm going to invite you to do is visit the drinkhrw.com /superhuman website and check out the research for yourself. If you're one of those people that needs to see it for yourself, that needs to dig into the research, I will tell you that this website, this company's website, is a wealth of information, and it's not just about them. It's just about all of the clinical trials, clinical studies, all of the research you could imagine on pretty much any topic you can imagine around molecular hydrogen to help you to make your own decision about whether or not this is right for you. Like I said, I personally recommend it to all of my clients. I use it myself every single day. But for some of you guys, and for many of you guys, we should always be informed. These guys have one of the best repositories of information on this compound out there. So drinkhrw.com/superhuman. And if you use promo code longevity10, you will save 10% on your purchase, anything that you buy, and you can use that promo code over and over and over again. So thank you so much for staying with me through this, and enjoy the episode. Welcome back, Dr. Lawrence. It is such a pleasure to see you again for our part 2 of our interview.
Well, thank you. It's a pleasure to be here. It's, as I've said before, it's actually a pleasure for me to be any place.
Well, as we talked about earlier, I think if all of us took on that attitude of gratitude, we would all be better off for it. But you do have very special set of circumstances that kind of ups the ante for you in that department. So I guess maybe what we'll do today, because this is part 2 of a 2-part series, people who are listening to this may not have listened to our first part yet. So maybe we can start with a very kind of condensed version of your story, what brought you here, and a little bit about what we're talking about today.
Sure.
And why you're so happy to wake up every morning.
Yes, truly. Okay. I've had several careers. I started professional career as an attorney out of UCLA, tax, estate planning, corporate taxation, and so forth. But I get easily bored with something once I've learned how to do it. For me, it's the learning process that I love, and so I went on and was sort of an entrepreneur for, I don't know, maybe a decade. I was building medical buildings and shopping centers and radio stations and a whole bunch of stuff. The worst period of my life, because I've realized I'm basically a hermit, and I shouldn't try to pretend to be an entrepreneur where you have to be out there in the world. So a bad mismatch. Anyway, so then I went back to school, got a master's in psychology. I tend to be, you would call me obsessive, probably, so forth and so forth. Did that for a while. The problem with that, though, is I was doing some therapy work, and the patients or the clients expect you to show up regularly. Otherwise, you facilitate all their abandonment issues. Even my therapist won't show up. So anyway,
I must really be in bad shape. Yeah. Okay.
Yeah, did that for a while. Anyway, then my father died, and I have probably the world's worst longevity ancestry history. All the males in my family line going back 200 years, and we know that because the church that I was raised in does a lot of genealogy work. So we had birth and death information on people going back literally 200 years. Not everybody, but a sprinkling. And it became clear that no male in my family line had lived to beyond 70, and only one man made it to 70, an uncle of mine. And uncles and grandfathers died in their mid-50s. My father had his first myocardial infarction at 57, fatal at 65. And at that point, I was in the middle of all of my entrepreneurial stuff, and I knew the family history, and I thought, is it important that I make another million or several $1 million, or is it important that I maybe be around to spend the money I've accumulated?
Very good thought process. I love that.
Yes. Yeah, a very easy choice, that one. And so I sold everything, went back to school. I got a Ph.D. in nutritional science, and have for the last 30 years been working in the field, primarily in the field of human longevity. And let me think. I guess about 7 or 8 years ago, 6 years ago, I teamed up with an institute out of Russia that was far ahead of the rest of the world in the field that I was working in, longevity. So, and what motivates me, of course, is I'll be 75 in September. And I'm 5 years older than any male that's ever survived in my family line. And I have a large family, 11 of us, and 3 of my siblings in their 60s have died in the last 3 years. A niece just died a few months ago at age 40.
Wow.
So what drives me is doing everything that I can to wake up tomorrow morning and 10 years from now and 20 years from now. And so my time is spent doing research on longevity and what we call health span. There's a difference, as you know, Nathalie.
Yep, absolutely.
And you have to have both. It isn't enough just to have a long life. You've got to have a long, healthy life so you don't spend the last 10 years in a nursing home. So that's basically, for the last 30 years, that's what I've been doing.
Amazing. And I guess one other little piece of information for the people who haven't watched the first episode is not only have you made it to the advanced age of 75 for your lifeline, and we're going to talk about part of this today. And if you haven't listened to the first episode, I really encourage you guys to do so, because in the first episode, we talked about the, I guess, interim results, if you will, or results after 3 years of a clinical trial with, I guess it's the first part of the trial is with 39 people that Dr. Lawrence is working with and measuring their telomere length. So this is the length of those little shoelaces on the end of DNA that you can explain much more articulately what that signifies, and also DNA methylation patterns to establish what people's biological age is versus their chronological age. And your biological age is pretty impressive compared to your chronological age by any measure, like family history or no family history. What you've managed to achieve now, and this is using bioregulator peptides, which are the stars of the show today, next to you, right after you. But using through the use of the strategic use of bioregulator peptides over the last number of years, Dr. Lawrence's biological age is now that of a 35-year-old versus his chronological age of 75 years old. And in the first episode, we talked about some of the results of some of the people in the clinical trial. And today we're going to talk about the DNA methylation results. Did I leave anything out there?
No, you did a great job of summarizing.
Right. So we're still there. So telomeres was our first, like I said, telomeres was the first interview. We talk about those at length. I think maybe in your slides today, you might have a little bit of a summary of that part. And today we're going to talk about DNA methylation. So I don't exactly know what your slides look like. So do you want to jump right into DNA methylation, or do we want to go to the slides? Did you include some of the background in that as well?
Well, I put it all in one PowerPoint presentation, so
Perfect.
We'll just start through that. Let me bring that up. Okay.
There it is. Perfect.
Yeah, a client of mine actually put this little slide together. He says that's Lawrence trying to pull that clock backwards and so forth.
Love it.
I thought it was cute. Yeah.
That is very cute.
Okay, let me get up here to the slideshow.
Perfect.
Okay, I think away we go, Nathalie.
Ready for liftoff.
Okay. This is the aging paradigm that pretty much everybody has. You know, we start, youthful and so forth, and over the period of 7 decades, 8 decades for some people, we end up, becoming old, frail, health issues and so forth. But that's pretty much the accepted aging paradigm. One of the goals I have and the Institute has is to change that paradigm, and we'll show that a little bit later. So there are many theories of aging. In other words, there are lots of ways to intervene in the aging process, and all of them are important. Years ago, I don't know, 20 years ago, I decided that I needed to find the most effective what I call high leverage. In other words, things that I could do that would give pretty immediate types of benefits. And doing the research that I was doing, I determined that probably modification of telomeres, also working with DNA methylation and organ regeneration, which is not shown on here, would probably be very important areas. I also included hormone replacement, and obviously as foundation, you have to deal with diet, clean up the diet. I was fortunate that let me think, even before my father's death, I had replaced the standard American diet with a much healthier diet. It's difficult to have a clean diet in this country because of the processed food and the pesticides and the glyphosate and all the rest of that stuff. So, but anyway, so I focused on telomere DNA damage, and we're going to talk about that in just a little bit. I'm affiliated with an institute in St. Petersburg, Russia. I'm affiliated with them because when, 10 years or so ago, when Google Translator, well, less than that, probably 7 or 8 years ago, when Google Translator became widely available, I could start reading clinical studies out of China, Russia, various other places, and I realized that this group of Russians were light years ahead in the narrow area that I was interested in, which was telomeres at that point strictly. And so this is the group that I work with. I basically went knocking on their door, 6, 7 years ago. Mm-hmm. And they were gracious enough, notwithstanding the American-Russian, relations, at least at the government level, they were gracious enough to allow me to come in and eventually join them. This is Professor Khavinson. He's my direct boss. The clinical studies that we're talking about, the telomere and the DNA, are joint Russian-American clinical studies. I am the director or administrator, basically, of those studies, but I report back to Professor Khavinson. Professor Khavinson is extremely well known in Europe and pretty much the rest of the world, unknown here in America. He's been the president of various associations all over Europe having to do with gerontology and so forth. So little quick back. Oh, yes, this Professor Khavinson on the right, 2 years ago, received Russia's highest civilian award called the Freedom Award for his 40 some odd years, initially in the military as a medical doctor, scientist, and then later with the clinic and the institute for his years and years of service to the Russian people. What he's saying is basically that these peptides that we're going to talk about today are going to become the most crucial development. They are going to replace most pharmaceutical drugs because they are so effective, far more effective than most pharmaceutical drugs, and without any side effects. Mm-hmm. I say kind of with a joke that's his boss standing to his right. President Putin, as probably people know, even in America, is very focused on his own health. Mm-hmm. And without saying too much, I've never seen President Putin in the Institute. I see his personal physician there frequently, carting out boxes and boxes of peptides.
No doubt. No doubt.
Anyway, so what peptides are, as Professor Khavinson explains here, they're signal molecules that that regulate gene expression. They also are important in terms of cell differentiation and so forth. And when he says they increase the life-sustaining resources, we're going to see later in some data slides what that really looks like. Okay. The background, real quick, these peptides is that the Soviet military, back in the 60s and 70s, were sending out submarine personnel, young submarine sailors, and the officers, men in their 20s and 30s, on short, what we would consider today short missions, 3 months, 4 months at a time. And they were coming back in these submarines that were built in the 50s and 60s with a nuclear reactor inside with very poor protection. They were coming back with all sorts of medical issues, as you can imagine.
Yeah.
Particularly immune system, thymus system issues and so forth. And so the Soviet Union said, we can't have this happening. And so they turned to Professor Khavinson, who was a military doctor scientist at the time, and a group of other scientists, and said, you need to figure out how to regenerate or how to rehabilitate these sailors and so forth. And so they threw lots and lots of money. Professor Khavison tells me that the amounts today would be astronomical and not even possible given the dollars in those days that they used. So what they did was, most people I think understand that very few scientific discoveries are just, a scientist waking up in the morning with that light bulb above his or her head that goes on. The way that it works is you build on the discoveries of those prior to you. And that's, of course, what happened with these peptide bioregulators. This is Ivan Pavlov. Most people are familiar with his name based on the digestive studies that he was doing, particularly with the dogs, what we call classical conditioning with the dogs. But what he really is well known for in Russia are his studies, his physiology studies on the human digestive system. And he really began to understand that process and the role of not peptides, but proteins. And we're going to talk quickly later, but peptides are simply small proteins. Scientifically, they arbitrarily have a dividing line. If you have a whole chain of what we call amino acids, up to 50 of them, that's called a peptide. If you have 50 or more, it's called a protein. So it's a size differential between the two. But there's some dramatic benefits of a short chain of peptides versus a protein that we'll chat about. So this is Professor Khavinson in the military in charge of this development program. And they started using them for the submarine people very successfully. They were able to rehabilitate the thymus, and then the pineal gland was the second peptide bioregulator they came up with. And they used them then it spread to the general military as well. They used them in the cosmonaut program, what we call the astronaut program. They used them to recover after, the cosmonauts would return to Earth and so forth. I couldn't bear to take this one out. This is my cutest one. This is Misha. Both the Americans and the Russians, they obviously started with animals in terms of their space, work and the space exploration and sending, rocket ships and all that stuff up. And so this is little Misha, and I just love her little, space helmet that's sitting there next to her.
It's spectacular.
Yeah, it is. I should take it out of the slide presentation, but I can't.
It's okay. She's okay. Worth 10 seconds. We're good.
Yeah. Okay. The Russians use the peptide bioregulators with their Olympic teams, again, mostly for recovery, both in terms of training as well as competing and so forth, because they have muscle peptides, they have cartilage peptides that restore muscles, restore cartilage and so forth, things that basically we can't do very well here in the United States. As I said, peptides are simply small little chains of amino acids, and amino acids are the molecules that come out of food, and I'll explain in a moment how they become peptide bioregulators. So you have amino acids over here on my left here, and that's just little molecules that come out of a plant. They come out of animal food and so forth. When you start stringing them together, then they can become active in terms of doing things that are helpful in the body. And the Russians figured out, based on Pavlov's work, and then Khavinson's work, that if you have very short string, mostly three of these together, they're so small when there's just three of these amino acids that they can go right through the digestive system intact. They can pass through the cellular membrane, which is critical, and they can also pass through the blood-brain membrane as well. In other words, they can get into the cells and do things that we're going to talk about in a few moments.
And they pass the nuclear membrane as well, right?
Yes, absolutely. That's why. But if you get the more amino acids, that is, the longer the peptide bond, as we call it, then the less absorption that you will have. And when you get to a protein, it's even less.
Right. And I guess so my understanding on the bigger peptides that are not the bioregulators, so the ones like BPC-157 or thymosin beta-4 that are 15 and 43 amino acids long. I mean, these are still tiny molecules, but they're much, much bigger than the bioregulators we're talking about today. So whereas the bioregulator actually can cross into the nucleus and bind to actual DNA to initiate protein synthesis, those bigger peptides are therefore relegated to bind to receptors maybe on the cell membrane to initiate cascades of events within the cell, but they kind of work from the outside in.
Well done. Exactly. In fact, we're going to show in a moment. I think I left this one in. I did.
Oh, you
did. Your timing is amazing.
Oh.
Okay. So what we have here in the center here, this is the peptide. Okay. And it's a 3 amino acids. Happens to be the pancreas peptide. It's 3 amino acids. So there's little clumps of 3, different colors here. I think red, blue, and white are the colors. So you clump these little amino acids together in a substance, okay, put it in a capsule or whatever. And what happens is that it's absorbed, and this is the DNA, okay, here. Okay.
So we can't see your pointer here. So people, what Dr. Lawrence is pointing to, pancreagen is the pancreas. It's the pancreatic bioregulator. And to the left here, what you're actually seeing is DNA, and you're seeing this magical, how it just fits. The amino acids line up and they're attracted to their site, if you will, on the DNA specifically.
Yes, absolutely. Okay. So we use the peptides for longevity. We also use them to mitigate health issues. And so this happens to be a study that I decided to leave in here. This is Gazprom, a very large oil and gas operation in Russia, Ukraine, and so forth. They were doing what we call a morbidity study. In other words, they wanted to find out if they could use these peptides to reduce sickness and days away from work. So they did a study, 11,000 some odd employees who went on 6 different bioregulators. And Natalie, I guess you can't see the little laser thing at all, can you?
No.
Okay. So they use the immune system peptide. They use the brain. They use the arterial blood vessel peptide, the bronchi, which is respiratory, the liver, and the cartilage. And they gave these to these employees, 11,000 of them, for 1 year. The control group of 3,000 employees did not use any of the peptides. They just used their normal vitamins and things of that nature. At the end of a year, again, we're looking at sickness and days away from work. The purple over on the left is the control group, and I don't have the numbers there, but we're showing the concept here. With the peptide group, there was a reduction of 2.7 times the amount of sickness due to respiratory issues. And with regard to total, what we call morbidity or total sickness, days away, there was a reduction of 2.3 times versus the control group. In other words, go ahead.
Question for you. So it said in the last slide that the control group got multivitamins for 30 days.
It may have been 30 days. What they were making the point was that they didn't get anything in the way of peptides.
Right. So they just didn't get peptides. So
yeah, they just did whatever they do. Okay.
All right.
And I can't remember from the details of the study if they were provided vitamins for 30 days or whatever the case may be.
Okay.
The idea behind it was you had a control group, no peptides. You had a very large group using peptides. What was the benefit? And
Right.
as you can
And
see
nobody
here,
knew what they were taking anyway. So there would be
yeah,
no
right,
expectation on
right.
anyone's part. Plus, these people are working in Siberia, guys. So, and they're working for, in Siberia in really tough conditions, high stress levels, not the most cozy, comfy living conditions you can imagine.
Yes.
So everybody's kind of struggling here, and nobody's expecting that they're being given these life-changing substances, really, I would imagine.
Okay, so I'm going to quickly go through this because I want to get to the DNA methylation.
Yeah.
To demonstrate the effectiveness, the peptide bioregulators, it's not easy, but it's you can see the results, no pun intended, by looking at vision or retina scans.
Mhm.
So we have a bunch of before and afters coming up here where before treatment. So on the left, at least my left that I'm looking at here, this is a field of vision scan. And what you see here, what you want is all green. That means good vision. So on the left, you see it here with diabetic retinoplasty that there is some green in the center, but where you see the black and the red and the yellow, that means there's degrees of impairment. And of course, black means you have no vision. Red means, very limited. Yellow is problematic. And so this patient on the left started at that baseline after a couple of years of treatment. And I don't remember for each of these slides how long, but a couple of years with the peptide bioregulators got the result that we see on the right, where there's mostly green and just a little scattered red and yellow and black. And so the difference is the person on the left probably really struggled to go through life with limited vision. The person on the right probably just had a minor little bit of interference. The interesting thing is that here in the States, there is really no effective pharmaceutical or medical intervention for retina issues. There's some eye drops that are used and some experimental things and so forth. But the Russians have been treating with bioregulators for 30 years, these kinds of conditions very successfully. So quickly, here's retinitis pigmentosa. Again, you see on the left, lots of black, and on the right, a lot more green and less black and so forth.
Unbelievable.
With
and retinitis pigmentosa is considered, again, untreatable in North America.
It's a progressive disease, untreatable, at least in America. Macular degeneration, I would say if between the two, I would say there's a 60 to 70% improvement between the two field of vision scans. And glaucoma, the same thing. These are harder to see, but you see a lot more green on the right-hand side and less black. So,
unbelievable.
Yeah, so that basically is the power of these peptides, and that type of thing is true for all of the organs, all the major organs, because there's 23 of what we call the natural peptides, organ specific. And the interesting thing about the peptides is similar here in America to the thyroid. I think you call Armor. The natural one is called Armor, and I think the synthetic is Synthroid.
Yeah, so desiccated thyroid, which is actually taking desiccated thyroid gland.
Right. Yeah, so let's actually quickly talk about the source. I didn't talk about that. Just like the Armor comes from pigs, these peptides are derived from 12-month-old calves that are very carefully raised, and then their organs are taken. They're filtered, processed very, very carefully, and they extract the amino acids from the tissues of a particular part of the calves. And so they extract the tissue or the amino acids from, let's say, the retina, the pancreas, the kidney, the liver, the brain, basically all the major organs. So there's 23 of these various natural, what we call natural or cytomax peptides. The interesting thing is that when you take, let's say, the pancreas peptide, since we showed the DNA bonding, if you take a pancreas peptide and you swallow it, or you take it by injection, some of them are injectables, the peptide goes to the designated organ. It's, or what we call organ specific. So it travels through the body, the blood, the tissues and so forth, and ends up binding with the pancreas, okay? Or the brain peptide goes to the brain, and the liver peptide goes to the liver, and so forth. So now we're at the epigenetic methylation study.
Actually, one more thing before we get into that. The peptides that you're using in your clinical trial are the oral, for the most part, the oral actual animal extraction.
They are strictly the animal oral capsules. The peptides from the Institute come in a variety of forms. They come as sublinguals, they come as injectables, but we only use the oral capsules for the clinical study, because we want to be consistent and show that the capsules that anybody can swallow are safe, and secondly, that they're effective.
Right.
And so we don't use anything other than the oral capsules.
Great.
Okay. Methylation, very, very complex subject. There are entire medical textbooks, many textbooks written about methylation. It's a chemical process. And when I try and explain it, I sometimes revert to, it's like you have this huge chemical factory. Okay, it's called our body. Okay, and it's processing all sorts of chemicals. And those chemicals, as you can see here from the slide, Nathalie, is our photo blocking some of that?
Nope, I don't think so.
Okay, good.
On the far right, I'm seeing like, on the left, there's like this beautiful orange sun, and on the right, it kind of ends with a dotted line in the bottom right-hand corner. Is there anything else to it?
No, but you can read everything.
Yeah, neurotransmitter production, detoxification, histamine metabolism.
Okay, good. Okay.
Yeah.
Because I want people to be able to see the information and not your pretty face.
No, my face is very small on the side where it should be.
Okay, good. Okay, good. Anyway,
way off to the side.
Okay, good. So it's a biochemical process, methylation, and it's vital. We can't live without methylation occurring. Okay, it's important for every aspect, as you can see the list down here, and that list is just a small sampling of what happens. So it's a chemical process that goes on literally 1 billion times a second. I mean, it's an amazing process. I'm not going to read this because this is going to be YouTube. People can look at it at their leisure and so forth. It is fundamental. Methylation is fundamental to energy processing. We don't have energy if you don't have methylation.
Right.
And it can get more technical. This is a little bit more of the technical part of it, where Dr. Horvitz is talking about that it's chemical changes to something we call cysteine, which is part of a DNA base, or some of the letters, as he talks about in the genetic code. And basically what happens is that there are changes in our DNA that are impacted by changes in methylation. And his group of scientists, Dr. Horvitz at UCLA, they spent years and years studying all of this. And what they discovered, very oversimplified, is that as we age, that there are changes to the chemical factory output of what I would call methylation, and that the changes turn on genes that are sort of anti-aging, but they turn off genes. I'm getting this backwards. What they do is it turns on genes that truly are anti-aging. That is, you don't want them around because they interfere with the aging process. Okay, I'm mixing this up.
And I'll help you out here. It turns on. It basically, if you imagine genes as being switches, so it flips the pro-aging switch up so that you get more degradation, and it turns down the anti-aging switch. So something that might support rejuvenation, right? We rejuvenate when we're young quite effectively. And as we age, those rejuvenation processes start to wind down a little bit. We're less able to repair and restore from damage, if you will, for whatever reason.
Yes, thank you. In Russia, we talk about anti-aging in a different way than we talk about it here in America. So what happens, as you've said, is that we have genes that get turned off that relate to aging that we don't want turned off as we age. We also have genes that get turned on that we don't want to have turned on. So the system has gone awry, basically. The chemical plant is putting out things that are become toxic and not helpful at this point. So Dr. Horvath's team spent years and years. When I say his team, there were 60 some odd scientists from around the world working on this.
Wow.
And what they did was they figured out that this methylation, I call it dysfunction, or where you're switching, around to a toxic situation in terms of aging, where they knew it was going on. They didn't know why, but what they did figure out after 5 years of work and building on other, what we call clocks, methylation clocks, aging clocks, they did figure out how to measure it. And the measurement is fascinating. They can, with fairly effectively, they're able to, in terms of accuracy, they're able to figure out, by looking at these methylated, what we call GPC islands, they're able to look at and tell you basically from a biological standpoint how your aging biologically differs from your chronological age.
Mm-hmm.
And what they did was they took 13,000 blood samples that had been stored, where people had given, a blood sample for, say, just a general physician checkup, but the blood had been stored by LabCorp, by Quest, and so forth, 20 years earlier, and the people had died. So they had the death information, they had the stored blood, and so they went through and they did their logarithm analysis that was proprietary. That is, they literally created it. And what they were able to do was, by looking at that stored blood 20 years earlier, they were able to predict within about 1.7 to 2 years the longevity of that individual.
Wow. So at what age that person would have died? So they were able to, based on the blood samples that they looked at, without knowing that person's age of death, they were within 1.7 to 2 years close of when that person died.
Yes, exactly.
That's super cool.
Exactly, yeah. So what they're using it for at the moment is to determine if a person has accelerated aging. In other words, they can look at this and say, well, based on your blood work and so forth, and these methylation things that are going on, you're aging 4 years faster than your chronological age. They don't know why that is, and as we'll get to, this is the more scientific explanation, where it's a hypomethylation versus a hypermethylation. But let's skip through this, as Nathalie has already given us a good explanation. So in the telomere section that we did before, telomeres I liken to the tires on an automobile, because what telomeres are, as Nathalie said, they're the end caps on our chromosomes. And every time the cell replicates, we lose a little bit of that end cap. And when you lose enough of that end cap, then what we start to see at that point is old age sets in. People become vulnerable to various diseases, and they become frail and so forth, and they start falling, etc. So the telomere study is basically how to re-lengthen those telomeres, and so that's why I use the tire analogy.
Yeah.
So the DNA methylation differs from that, in that the DNA methylation is looking at, if we use the car metaphor, is looking at all of the running components, the engine, the transmission, the computer, onboard computer system. It's looking and measuring, you might say, the biological age of all these component parts to come up with an average biological age for the vehicle.
Okay, because it's looking at a master DNA, right? It's not looking, because you can look at I know you can look at telomeres specifically for cardiac muscle, or like organ specific.
Yes.
DNA methylation, is that the same as well, that you can look for DNA methylation patterns that are organ specific? But in the context of the study that you're doing, you're kind of taking a global look at DNA methylation
Yes,
of the system.
the level of testing and reporting that's available now commercially, to us, basically is giving you an average DNA methylation biological age for the human body. They do have the ability to be more specific, but only at the university lab level at this point in time.
Okay, great.
Okay, so what I want people to understand is telomeres are tire tread, and DNA methylation is the running components, or in this case, all of the organs and so forth. People don't realize there's 78 identifiable, at least at this point, scientifically identifiable organs and systems in the human body. People tend to think in terms of, well, there's the liver, there's the kidney, there's the pancreas, and so forth. There's actually 78 organs.
Wow.
Okay. Yeah. So Professor Horvath published a couple of years ago, basically his what's called the Horvath epigenetic clock, where he was saying, look, we can basically tell you the difference between your chronological age and your biological age. And why is that important? Well, Horvath says it's probably handy to know that you're aging quicker than your chronological and you might want to do something about it. But what he then says is, unfortunately, we don't know exactly why this is happening. We know it's associated with methylation issues, but more importantly, we don't know how to fix it. I'm going to come back to this epigenetics in a moment.
Yep.
So what they're doing is this, basically, it's a metaphor here. They're measuring the biological age of all of the working components of the human body, you might say. And that's over an exaggeration, but that's the concept. Let's come back to this. I want to go, what he found, or when I say he, 60 scientists and he, what they found, I'm sorry, what's that?
What he and his team found, yes.
Yes, and it's a big team, and it's a team all over the world. I mean, really bright people. What they found was that if you are 8 or more years older, biologically or DNA methylation wise, than your calendar age, you have double the risk of dying compared to your same age peers. On the other side of it, if you're 7 years, he says slower, if you're 7 years younger, I'll call it, than your chronological age, you have half the risk of death compared to your peers.
Cool. All right.
Okay. So this is a graph that I put together that shows basically that. So if we look at the x-axis, that's the years older than your calendar age, and it goes from 0 up to basically up to 8. Okay, that's as far as their research took us. And on the y-axis here, we have the percentage increase in mortality risk. And we're going to come back to this graph a couple of times. So now I'm showing this as a linear progression. It's not, okay? No. But the idea is to show you that there is a relationship between being older DNA-wise than your calendar age. Now, the other side of that is where you're younger than your DNA is younger than your calendar age, you have a decreased mortality risk. And so, for instance, if you look at the number 5, this person's 5 years younger than their chronological age DNA-wise, they have a 35% reduced mortality risk compared to their peers.
Right. So I think to the people listening to this, what's important to talk about here is we're getting to is that Dr. Lawrence and his work that he's done is now showing that it is possible to influence these numbers. And we know that lifestyle, diet, all of these things can really help. But what we're getting at here is that there are things that can be done that seem to be able to create a reversal and improve people's outcomes. And notice that it's 35% reduced risk of death. So it's not 0%. So things can still go sideways, but the odds start to move in people's favors, let's say.
Well summarized, Nathalie. I went back to this cancer one because they also discovered that for each 1 year increase between chronological and what we call this epigenetic age, okay, it's the DNA methylation epigenetic
Yeah.
age, there was a 6% increased risk of developing cancer within the next 3 years, and a 17% increased risk in the next of dying of cancer in the next 5 years.
And so that's for every 1 year increase in that gap between your chronological and biological age.
Yes.
Wow. So even at 1 year, you're starting to see a significant, a not
increase in risk.
Increase. Yeah.
Yeah. I think there was one other slide that I skipped through.
I think go back a couple more, maybe. There it is.
Epigenetics. Yeah.
Yeah.
So what's going on here is most people think that genetics are a huge influencer of what happens in our life in terms of biologically and so forth. And back in the day, I would say 30 years ago when I began working in this field, the thought was that it was probably 50% of what's going to happen in a person's life is controlled by their genes. Over the years, as their science has gotten more sophisticated, they've realized that genes are not that controlling. They're certainly very significant, but most recently, I saw an article a few months ago where they're estimating, they think that gene impact is probably somewhere in the area of now of 10 or 15%.
Yeah.
Because the whole field of epigenetics has been growing up. And what epigenetics is all of the other factors other than genetics that impact our health, our longevity, etc. And this can be things like stress. It can be the environment that we live in. It's what we eat, our diet, and so forth. How physically active we are or are not. I mean, virtually everything else that goes on falls into the field of epigenetics. And as the gene influence has waned or decreased, the epigenetics has grown because we now have enough clinical studies and experience that we see that people are not hostage to their genes. They, in fact, can have a huge amount of say-so about what happens to them biologically based on epigenetics, basically how they create their life in terms of biological impact.
Love it. Yeah. And this is what we repeat to people over and over again. You can, it's your genes load the gun in your environment, or the things that you do is what ultimately pulls the trigger or throws on the safety catch. Right. So you have a lot more control, and for some people, sometimes you wonder if they even want that control, but definitely for people to get their heads around that they can control or have a very significant impact on their health and outcome, it's a powerful realization. And for many people, it's what really moves them to take those positive steps in their lifestyle and the things that they do.
And the really good news about this is that because we've realized that epigenetics trumps genetics, you therefore have the ability to control a tremendous amount of what happens to you. I'm actually a pretty good example of that.
Yeah, exactly. You are a walking, breathing example of that, for sure.
Yeah, the genetics in my family, it has to be driven, somewhat significantly by genetics, but also, the lifestyle. I know enough about my family over the generations and so forth. They basically lived in fairly toxic environments, and the men didn't take care of themselves, and that's why heart disease was killing everybody, etc. Now we get to, before I leave that, so I am so pleased that with the science world of epigenetics growing as it is, what that says is I do have control, and I'm 5 years older than the oldest man that's ever lived, which is, I think, proof that epigenetics really has a tremendous impact.
Yeah. And you're taking epigenetic influence to the next level with these bioregulators, which is what we're going to get to here.
Yes, right? That's right around the corner. In fact, it's almost the next slide. So Stephen Horvath, brilliant, wonderful man. But what he says is, well, yeah, it's great we can measure this. And let's say that you're 5 years older. He doesn't see that is really very useful because we don't have a pill or an intervention. Okay.
Yeah. Now I have a question for you. Have you ever spoken to Dr. Horvath?
No.
Interesting. I'll bet you if he had any inkling of what you're doing, he might be super interested to talk to you, because you take this statement and spin it on its head, or it would seem that way anyway, without getting too crazy. But it sure would appear.
Yeah. As a hermit, I won't be reaching out to him.
All right. Well, I don't know.
Yeah. But no,
we might have to arrange that discussion someday.
Well, I for a lot of reasons, not just because I'm a hermit. The Russians and I are kind of keeping a low profile, and I won't spend much time on it. It's not because of the American-Russian thing, where the Russians get blamed for everything, including the weather. It has to do with the FDA and the pharmaceutical industry. In a couple of years, we're convinced, the Russians and I, both my attorney brain and my scientist brain, are convinced that the pharmaceutical industry, because the nutraceutical field is a multi-billion-dollar industry now, they're going to decide that they want the FDA to declare aging as a disease, because aging is not a disease here. And when that happens, there's going to be a huge change in the nutraceutical field. You're not going to be able to make claims that this will intervene with your anti-aging program, this will modify, this will help, and so forth. So we're kind of, because you're going to see here in a moment, we are making incredible interventions in longevity. And so we just kind of want to be off the radar. So I'll wait for Dr. Horvath to give me an email someday.
All right, fair enough.
Okay, here we go. So the Russians were aware of all of this certainly by 2015. Actually, in the late 90s, they were, but they started publishing some information in 2015. And the translation of that from science language into lay language is that the peptides can influence or regulate gene expression. And that statement may not sound very important, but it is huge.
It's big news.
Yeah, big news. Yeah. And now we're going to show you the data. Okay. So when I was first starting a couple of years ago to set this study up, Professor Khavinson and I, what we did was we took people who had been on the telomere study for at least 2 years or more, because the telomere study started basically in about 2015. So we had people on the telomere study for a number of years. So I took at random 9 subjects, tested them, because the testing only really commercially became available in late 2000, sometime in 2018.
Okay.
Commercial testing for this DNA. So I took 9 people who had been in the telomere program for at least 2 years or more, tested them, and their baseline tests on average among the 9 people, they came in at 5.5 years, 5.42 years for 2 years, younger than their chronological age. Chronological age is the black line in the middle.
Right.
So these were people who had been on peptides for a couple of years. Now, it's not evidence. It's basically at most proof of concept. It's as an attorney, it's kind of suggestive, interesting data.
Yeah.
But what it suggests is that it looks like maybe these peptide bioregulators can intervene, unless unless there was some magical picking, like lottery tickets of 9 people who at baseline were younger, which is not the case. These people were younger than their chronological age. So the other side, the green side that you see there, I also took then 15 people who had never been on peptides and tested them for their baseline. And the baseline for those 15 people came in almost 2 years older than their chronological age, on average.
Right. Okay. And how old were is there a commonality in terms of age, or were they all over the map in terms of
all over the map?
Okay.
Well, when I say all over the map, probably at that point, nobody less than 40.
Okay. Perfect.
But I think the oldest person was 90.
Wow. Okay.
Okay. So again, not evidence. It's data that is what we call proof of concept. It's suggestive. Okay.
Well, because you don't have the information for those 9 subjects who were 5.5 years younger than their chronological age. You don't know where they were when they started, before they started the telomere lengthening program. So exactly. So now moving forward, you're going to start getting that kind of data as you're doing your baseline before people even start. And then
exactly.
Okay. Great.
Yeah, because the testing wasn't available until about 2018.
That is amazing how new that science is, right? That's so cool.
Yeah. Okay, so you always experiment on yourself if you're an ethical scientist, as far as I'm concerned. And so
For
this
sure.
is this was my baseline. I had been on peptides for I don't know, 3 or 4, maybe 5 years. Yeah, probably 5 years at this point. So well, it was almost 3 years ago. My chronological age is 72 there. And my DNA age, as this lab calls it, in other words, the DNA methylation age, was 64. So I am 8 years younger than my chronological age
At that point.
at baseline. Now let's see what that translates into in terms and I'm also in the 99th percentile compared to my same age peers. Okay. So let's see what that means. So if I'm 8 years younger, that means I'm in the category here, where it goes up to a maximum of 70. I have a 50% reduced mortality risk compared to other men at their age of 72.
Wow. Yeah. And
Okay.
that's not even men in your family at the age of 72.
Yes.
Which I think would change that percentage rather dramatically.
Yes.
If we had that data, which we obviously don't.
Yeah.
Can
Okay.
I ask a question? And you may be talking about this at some point, but have you found, and I may really be jumping the gun here, but have you found that there's a relationship between the shift in people's telomere age and people's shift in DNA methylation age? Or are you combining the two?
Oh, no, I'm not combining the two.
Did I articulate that properly?
Yes, I know what you're asking about. All the people in the clinical studies are enrolled in both studies, okay?
Okay.
So we see their telomere progress and we see their DNA progress. What I can tell you is that there seems to be little relationship between people's baseline telomere age, as we call it, okay, versus their DNA methylation age. Very little relationship there. In other words, I see people with really good telomeres and very poor DNA epigenetic clock numbers.
Okay.
Now, what is also interesting is that having done this for 5 years with telomeres, we can move the telomere marker within about 2 years of using the peptide bioregulators. And of course, we showed in the last telomere section some pretty dramatic telomere lengthening.
Yeah.
We're only about 2 years into the DNA methylation, and then COVID slowed us down. So I'm just now getting secondary testing from people in terms of their DNA. It's a slower process, as you would sort of guess, with the DNA, because the DNA methylation is addressing 78 organs and systems, and that may be part of it. There may be factors, the epigenetic factors, that are harder or that are more impactful on telomeres than they are on the DNA. Because we know, for instance, as we talked about in the telomere section, the number one thing that accelerates telomere loss is stress.
Yeah.
I suspect it's maybe true with the DNA, but we just don't have enough science and data at this point.
Right.
So this person shows you the opposite end. This was a baseline person. He's one of those 15 people that hadn't been on peptides. His chronological age is 57. His DNA age came back at 72.
Oh, that's a bit of a bummer.
That's a bummer. He's 15 years older DNA wise, okay?
Yeah.
And he's only 57 chronologically. So we go back to our chart, and the chart stops at basically 8 years older. So in his case, he's about at a 200, roughly a 190 or 185% increased risk compared to his peers of mortality.
For some reason or another, which, we can't define based on this information, but basically what this implies is there's enough in his system going sideways that just his risk of something going dramatically wrong.
Yes. And he's now, of course, in the clinical study. In fact, yeah, I bet. Yeah. And he's a health.
Where do I sign?
Yeah, and he's a health professional too.
Sure.
And very knowledgeable. Anyway, so we're just now, actually, this week, He's in Great Britain, and this week he's sending in his secondary samples. So yeah.
Wow.
Okay, so let's keep moving on. So this is a person whose baseline DNA and chronological was exactly the same. Okay.
Yeah.
She was in the 45th percentile, which is roughly halfway. Okay, compared to her peers. So we put her on a peptide bioregulator program, and I think it's 18 months later. This is April of 2019. Yeah, July of 18 months or more. So what we've done here is reduced her DNA age from 53 to 51.
Nice. So she's reclaimed 2 years.
Yes, but what that really means is that she's also a year older.
Mm-hmm.
Okay, so now there's a 3-year difference between her DNA age and her chronological age. Look at, she's moved up to the 81st percentile from the 45th.
Nice.
Now, when they get their test results and they go look at this, particularly the ones who've gotten their telomere results, and and after 2 years they're 25 years younger telomere wise, they look at this and they go, "Oh my God, I only got 2 years."
Yeah, they're pretty disappointed, I'm sure.
Yeah, they are. Until I start to explain to them that we're testing two different things, because what's the key is this next thing, and that is at 2 years, she has gone from sort of zero increased risk. That is, at her baseline, she had the same mortality risk as her peers.
Yeah.
She now at 2 years is 14% less.
Yeah.
So somebody comes to you and says, in 18 months, I can reduce your mortality risk by 14%.
It's pretty good.
Yeah.
No kidding.
There's nothing else out there in the medical, the pharmaceutical, the nutraceutical, the unconventional, the conventional medical world that can do that. That can say, look, here's a 14% decrease in your mortality risk.
And I also think it bears mentioning that in this particular clinical trial that you're doing, you're not directing people in any way in terms of what their diet should be, what their lifestyle should be, what they should be doing to mitigate stress. And so I'm sure that you're going to see significant variation without at this point being able to quantify why the variation is there. But, as time goes on and maybe you start to control for different things, if you should ever do that, you may find that, someone who changes their diet or starts meditating or has just gone through the 3 worst years of stress in their life and has still seen this improvement in DNA age versus this other person whose life just became perfect and now they've seen 10 years improvement. So there's all these other factors and influencers that you're not even controlling for or even trying to affect.
Yeah, that's exactly the situation. We don't make any changes in what the people are doing in terms of their lifestyle, etc. The only change that's going on is the addition of peptide bioregulators.
Right. And actually, one other question. Have you seen, from a trend perspective, do you see any difference between men and women?
No.
Have you noticed or looked for it to see, in general, men seem to respond faster, slower, women? Or you're not even looking at that at this point?
I'm not even looking at it. I am so focused, and sometimes I feel like I'm on a surfboard in front of a tsunami.
Just stay on track, whatever you do.
Yeah, my focus is, there's almost 100 people now, and since a year and a half ago, we only admit health professionals with a few exceptions, we only admit health professionals into the clinical studies. And I'm up to my eyeballs in just administering those clinical studies. So I'll leave it to other scientists down the road, once they understand what we can do with the peptide bioregulators, to start to tease out, the secondary effects. But I am convinced, of course, though, that if one is doing everything reasonably possible, clean diet, exercise, reducing stress, and so forth, intuitively, they probably are going to get better results quicker.
Yeah, no, for sure they are. Okay, let's keep going.
Let's go on. Okay, so this is, this is Daniel. Daniel is a health professional. His baseline in July of 2019, he was 2 years older DNA-wise than his chronological age, putting him at, a little bit increased risk. In fact, his risk at 2 years, he's 25% increased mortality risk compared to his same age peers where their chronological and DNA lined up the same, okay? So we put him on the program, I think 2 years plus at this point. And we reduced his DNA age to 52. He's now increased age-wise 2 years. So now there's a 4-year difference. Let me go back here. He was in the 16th percentile. Yeah.
At the beginning.
That point.
Yeah.
And here he's. Let me. Yeah. Okay. Okay, so now he's in the 86th percentile. He has a 4-year difference. I called this the gap, GAP, the gap, okay?
Yeah.
If you remember what we talked about in terms of Dr. Horvath's team found that if you're 8 years older,
yeah,
you have increased risk if you're 7 years younger, okay? So our goal with everybody in the study is to get them to at least 7 years younger than their chronological.
Mm-hmm.
And it's the gap that we measure. So sometimes people will focus on the DNA age and they'll say, well, but my DNA age only went down a year. In this case, I think it went down 2 years, okay, from 53 to 51. But you also have to look at the fact that you're 2 years older.
Yeah, exactly. So he slowed down.
Yeah. So it's the gap, I call the gap that we're looking at. This person has now a 4-year positive gap, I call it, in that he's 4 years younger. And if we go to the graph, he went from, I think it was a 28% increase risk. At 4 years younger, he has a 28% decrease risk.
Yeah.
At this point. I mean, he's went from high risk to low risk at this point.
Amazing. Amazing.
Smithsonian wrote an article recently summarizing a number of clinical studies that suggest that 150 years may be the upper limit for human lifespan. They basically are saying that it's possible that a human being could live that longer. Other scientists are saying 120 is the limit and so forth.
Yeah, that's what we hear typically. The most quoted number is 120. But
yes.
as you mentioned earlier, I think for a lot of people, certainly in my world or for me, I'm happy to live to 120, but I'm picky. I'm only willing to live that long if I can keep taking care of myself and keep my wits about me to a point.
Precisely, yeah, absolutely. Okay, so here's what this is all about. This is the kind of the summary in a sense. It's both enhanced lifespan, reduced mortality, and the way we do that is with organ regeneration. Okay, and here's the scientific data that proves that that's what we can do. Okay. So again, current aging expectations, okay, that most people have.
Yeah. So for those of you listening, not watching, we go from baby to child to thriving adult and now to stooped over elderly person.
So Professor Khavinson and I and the other scientists at the St. Petersburg Institute, we have a very different paradigm.
Look at that.
Yeah.
So after our stooped person, we have a very upright, we have that person in their prime reappearing, pretty much.
Yes, precisely. Now, here's the data. The peptides, as I mentioned earlier, are specific to 23 different systems and organs, okay? I would call them the primary ones, even though I mentioned earlier there's 78 human organs. There are at least 23 that are really primary.
Mm-hmm.
And what we're doing with the peptides is much like the thyroid that we talked about earlier with armor and so forth. I'm sorry, we were talking about thyroid.
Yeah,
Okay.
thyroid,
Yeah,
like
yeah,
desiccated
armor.
thyroid
Yeah, okay.
armor. Yeah.
What we're doing with the peptides is we can take these peptides, direct them to specific organs, and basically at the cellular tissue organ level, regenerate that organ. It would be like taking, a beloved 57 Chevy. I had a 57 Chevy when I was in high school.
Yeah.
I have a fondness for them. Yeah. It'd be like taking your beloved 57 Chevy in the year 2021
And
into a
restoring
master
it.
mechanic and
Yeah.
say, spare no expense. I want you to go through and fix everything in this vehicle, in the running components of it and so forth. So it's like brand new.
Mm-hmm.
That's, in a sense, I'm exaggerating a bit, but that's in a sense what we're doing with the peptides for organ regeneration. Now, let's see if there's some data that backs that up, or my attorney says, show me the evidence.
Yeah, exactly.
Okay, so this is a study that was done in Russia and the Ukraine. If we look at the elderly people, the yellow over on the left, that's an age group of 60 to 74-year-olds. And the control group in the middle, which means non-peptide people like peptides, they call it polyvitamins. In other words, just doing what they're doing with their multivitamins and so forth.
Mm-hmm.
If we drop down to, you see, Natalie, where it says mortality rate in the course of 12 years?
Yeah.
Okay, in the middle there.
Yeah.
So this study ran 12 years. They did some evaluations at 8 years, but it continued to 12 years. In the control group, the non-peptide group, 44% of these people died, which would be normal for that age group over that time frame. And the life in Russia and the Ukraine is a little more difficult. They don't have the same longevity that we have in the US, although the last couple of years, actually, longevity is decreasing in the US compared to what it's been always increasing. And so they're closing the gap because of the obesity, the diabetes that we have here and so forth. Anyway, the point is 44% of these people died in 12 years, normal for that age group. On the next column over, that's the pineal gland peptide. That's one peptide, one type of peptide, administered to that group. The mortality rate dropped in half to 22.3% with one peptide.
That's amazing. And so is this the study where they were administered this peptide only for 3 years? And then,
yes.
So they got this peptide for 3 years and probably in cycles. I mean, I don't know if you know the details. Were they taking the peptide for 12 months or
yes, they were.
They were, because typically the way people are told, and, a lot of this information is people are kind of guessing, or they're trying to interpret studies that they're getting their hands on. And there's this lore out there that says, oh, well, you want to be using the pineal peptide for one cycle every 6 months. But in this case, what they were doing is they used it for 12 months a year for 3 years. Then they stopped, and they were monitored for the next 9 years.
Yes.
So what's really interesting about this, I think, is that it's exactly what you were talking about. It's this regeneration of the pineal gland. It's only through regenerating that you will actually get this kind of long-lasting result.
Precisely. Yeah.
Right.
Unlike Western medicine, where they put you on a pharmaceutical and you have to stay on it basically for life, or at least that's the standard procedure.
Because it's doing the work, right?
Yeah. What we're doing here is we are truly regenerating organs such that after 3 years, for the next 9 years, there was no peptides used whatsoever, and the mortality rate dropped from 44 to 22%. Okay.
That's just amazing, right? And I think that what's important to highlight to people here is the importance of the pineal gland. So some of the people listening to this will know, but many people who may be coming to this podcast, this may be the first thing that their first exposure to this area, is understanding the role that the pineal gland plays in human health, and why anybody would maybe start with this one little tiny pea-sized organ or gland in your brain. And it is your master clock. It regulates circadian cycle, like circadian rhythm of the body, really from the top. It helps to upregulate melatonin production. And people are like, well, big deal. So maybe I'll sleep a little bit better. Well, what people, again, don't understand is all of the downstream effects of just these two things that can result in this amazing kind of data. So
yes, absolutely. What people can identify with is the pineal gland is the master regulator of our entire endocrine or hormonal system.
yeah.
That they'll connect the dots with that. That's how important it is.
Yeah.
Okay.
Yeah.
So let's go on in the interest of time.
Let's look at the old people.
Now be careful here.
Well, it says old people. Listen, I would not. Apparently, I'm geriatric by definition, right?
Okay, old people. Okay. The Russians are not the most diplomatic people on the earth.
No, but that's okay. You know what? We'll give it to them.
Yeah. We wouldn't call in a clinical study, and they use in the clinical study they call them old people. Anyway, these old people who are at least 2 months older than me at the moment, they're 75 to 89 years of age. The study was a 6-year study because, of course, of the age of the individuals. In the non-peptide group, what we call the control group, during that 6 years, 81.8 or almost 82% of these people died, which would be normal for that age over that 6 years.
Yeah, things start to go sideways big time at that age group.
Yes. So with the pineal peptide, the mortality rate or death rate was reduced to 45.8%, huge drop from 81.8.
No kidding.
In this study, they added a second peptide. That's the thymus peptide, the immune system. Okay.
Yeah.
And at that point, when they added the second peptide, the mortality rate dropped to 33.3%. So it went from almost 82% mortality rate to 33% over the 6 years.
Amazing.
Using 2 peptides.
And so do we know how long these people got the peptides for?
2 years.
2 years. Wow. And also, what was the other thing? Oh, yeah. How many? Do you have a sense of how many people were in the groups?
Oh, I don't. I think several hundred, but
we're talking hundreds, not like 10. We're not talking 10 people here.
No. Yeah. There are so many studies. There's probably 36 of these longevity studies that the Russians have run. And the smallest one that I've ever seen was 49 people.
Wow. Okay. Even the rat studies, they have hundreds of rats. Like it is.
Oh, yes.
I remember I heard Dr. Khavinson speak about this once. He's like, we had such big budgets. People don't realize how expensive lab rats are, but they were able to have 200 rats in every study.
Oh, yes.
Which is a luxury in this universe.
Yeah, every time they develop a new peptide, as I say, they have 23 of these natural ones. It's animal studies for years before they ever start running the clinical studies. But the nice thing is that because these are sourced from calves, they are completely safe. In fact, one scientist at a conference I was presenting at said, Bill, what you're really talking about here is nano steaks. And it took me a minute to figure out what he was saying. Yeah, we're giving people nano steaks, tiny little, tiny little steaks.
Yeah. Well, I think there's a correlation here to be seen also with people on true carnivore diets that are eating that nose to tail diet and consuming organs. Mm-hmm. Not that eating an organ is necessarily as powerful as taking a bioregulator peptide, but those bioregulator peptides are in the thymus, the liver, the kidneys that people are eating. So
yes.
I don't really think it's that much of a stretch to start to understand where in some cases people on these nose to tail carnivore diets are seeing such transformational health benefits. Probably because their bodies are getting access. Like the peptides are there. It just might not be quite as concentrated as you're getting in the supplement.
Yeah, these are 1,000 times more concentrated, 10,000 I wouldn't know, and so forth.
Yeah.
So there is nothing that I'm aware of, and I say I'm obsessed with this. This is what I've been doing for 30 years. There is no other intervention. There are other good interventions to keep you healthy and extend life. We think that basically calorie restriction based on animal studies might lengthen life by about 20%. Okay, that's sort of the going estimate at the moment.
Yeah.
There is nothing out there in the medical, pharmaceutical, conventional, unconventional field that I'm aware of that comes anywhere close to reducing mortality to this degree with a safe product.
Yeah. Yeah, with no side effects.
No
and
side
actually,
effects.
I don't know if you're done with your slide yet, because I have a couple of questions for you, but look at him.
I think only have a couple more.
Yeah. Okay.
Okay.
There's a cool car, though.
I had to throw this in. Okay. This is Irv Gordon is his name. He's an American. He had this 1966 Volvo, and he is the holder of the Guinness World Record for the highest number of miles driven in one vehicle. 3.2 million miles.
Oh my gosh, on this car.
He drove in this vehicle, okay? And he was able to do that because he maintained this thing just unbelievably. Now, what's interesting, and the reason I have it in there, if you look at Irv and you look at the vehicle, you can see that I think the vehicle was probably maintained better than Irv.
I had a feeling you were going there. So for those of you who are listening, Irv, you know, he's a happy guy. He's got a great tan, and he looks like he could probably stand to lose a few pounds. So
maybe 40 pounds or whatever. Yeah.
Like
and
that.
Unfortunately, the evidence of that, I'm a data guy, is Irv died last year at the age of 77.
Oh.
Yeah.
But the car's still running.
That's right. In fact, I think it was sold on eBay or it's listed on eBay or something. The point is this, of course, it's obvious. That is, if Irv had spent, some amount of time maintaining himself, I think he spent too much time sitting in the driver's seat.
Yeah, no kidding.
If he had maintained himself nearly as well as that vehicle, he could have lived another 10 years or so.
And put a couple more million miles on it. That's a pretty sweet car.
Yeah.
I like that car.
Okay, this is the last slide. This is what I call the bridge. The bridge basically is that the idea is that you have to stay as healthy as you possibly can today in order to take care or take advantage of the medical discoveries, the biological aging discoveries, things like peptide bioregulators and so forth, things like stem cells, exosomes, the DNA repair things that are available. They list on here telomeres and so forth, the cloning, all of these things that are being developed at the moment. And because I pay so much attention, I'm privy, not unique to me, I just happen to be where I'm looking all the time, to things that are amazing. Within 10 years, it is very reasonable that we're going to be able to control diabetes, we're going to be able to control heart disease, we're going to be able to control cancer. About last year, maybe even a little bit longer than that now, COVID kind of messes up the timing.
Yeah.
Some really bright Israeli scientists came up with an intervention, a chemical process intervention for cancer tested on a variety of different cancers. People use the complex, and I'm not at liberty to really explain what it is at this point.
Yeah.
They use this complex, basically swallowing capsules, much like the peptide bioregulators, for 3 weeks. It stopped the progression and reversed the progression of all the cancers that they were using in the clinical study.
You're kidding.
It won't be available probably for a decade or two in America. It'll be available in a year or two in Israel. Americans will go to Israel. It won't become available in America because the pharmaceutical industry, the medical industry, and the FDA are going to make it very, very difficult to get approval.
Yeah.
Even though it shows in the preliminary studies to be extremely safe, and they have human studies. We're not talking about mice and rats. We're talking about human studies. Unbelievable.
Okay.
Yeah.
Yeah.
Anyway, the point is, you've got to stay healthy in order to get the
Advantage.
benefits of what's available in 10 years. If you can get to the next 10 years and be healthy, you probably have leveraged up another 20 or 30 or 40 years, depending on how old you are at this point. For me, I believe that I can reach 100 and be about as healthy as I am today,
Yeah.
as long as I continue to do what I'm doing.
Yeah. No, it sure sounds like it. That's amazing. That is, guys, if that's not motivation, I don't know what is. To take care of the house. And one thing I wanted to say about type 2 diabetes, would you say that, and I mean, I know I don't want to get too specific here, but I would have imagined that there's, depending on the individual and a whole bunch of different factors, that there are certain bioregulators that can be quite helpful.
Absolutely.
There's a pancreas.
Absolutely. There's a specific bioregulator for the pancreas.
Yeah. Yeah. So, which is interesting. So there's lots of there's already so many incredible tools that are coming up at our disposal. And I think these peptide bioregulators are absolutely, well, they're so cutting edge. And it's funny because they're so cutting edge, and yet at the same time, it's a solution found in nature. Right?
Yes, that's the wonderful part about it.
Yeah.
There are virtually no side effects, and so the dosing there's no danger in dosing. You can overdose somebody with the peptides, and you don't have any fear other than wasting some money and having to swallow extra capsules. You're not going to harm them.
Yeah. And I think that what bears repeating here as well is this whole modulatory effect of the peptide on the target organ, gland, or system. What I mean by that, and the thyroid is one of the best examples for this, only because so many people, if you don't have it yourself, you probably know someone whose thyroid is underactive or overactive, less commonly overactive, but underactive. And what the thyroid bioregulator will do, it's not going to boost or suppress anything. It's going to normalize function. Because if you think about it, if you regenerate that gland, it should resume function as it was intended in the first place. I think that one of the things that people sometimes miss and that we have to talk about is, before you can bring the thyroid, and actually I may be talking out of turn here, but before you bring the thyroid bioregulator on board and can expect it to truly do its work, is there an immune process in the body where the body is attacking the thyroid? In which case you might have to deal with that before you can expect the bioregulator to do its thing. Or is there a deficiency of iodine or an excess of something that's blocking iodine or selenium? Like, all of those different cofactors that we need are necessary for the thyroid to do its work, need to be present before the bioregulator can do its thing. Would you agree with that? Or
Absolutely. Absolutely. The other thing is that in the institute, which has a medical clinic attached to it, they have the institute where they do the science and the development and so forth. They also then have a medical facility where Russians come in and can get treatment, and the treatment is 90% bioregulators. And people fly in from various parts of the world, prime ministers, et cetera, come in and get treatment. They'll typically stay for 2 weeks or so, and begin a course. Oftentimes it's with synthetics, because the synthetics are faster acting. But the long term is the natural peptide bioregulators. And they may come back every couple of years, particularly the vision people will come back, the retina people will come back once or twice a year for additional, because the retina issues are difficult. And the Russians never, ever, I shouldn't say never, ever to anything, but rarely use one peptide to address a regeneration. Yeah. It's always a combination of peptides, because unlike here in America, where the conventional doctors, if you go in with a medical problem that relates to, let's say, a kidney, they just address the kidney.
Yeah.
That's it. Okay. And their medical bag says inside kidney pharmaceuticals, and they prescribe it and so forth. The Russians don't do it that way. They know that it's part of a system. Okay. Mm-hmm. And so the typical if they're in Russia, if they were treating a condition, they would probably, like heart disease, they would probably use 5 different peptides: an arterial peptide, the heart peptide, the liver peptide, always the thymus peptide, almost always the pineal peptide. It's always a combination, almost always at least 3 peptides at a time for regeneration.
Yeah.
Now, here in the clinical study, we're not treating medical conditions. We're treating aging, which in the United States is not considered a medical condition or a disease. But we use, I would say the average person in the clinical study is probably using 5 or 6 different peptides every month.
Yeah.
The reason for that is I have a sense of, after doing this for a number of years, I have a sense of which peptides that are most effective for telomerase activation or telomere lengthening.
Mm-hmm.
We don't know at this point exactly what we have to do in terms of DNA methylation to affect that regeneration and reducing the biological age, as they call it. As Horvath says, we don't have a pill. Well, we have a whole bunch of pills, but I don't know which ones. And so we use them all on the theory that since Horvath's clock, epigenetic clock, is measuring biological age of the system, we're assuming that the component parts need to be addressed. And so we use all 23 peptides over the course of a year to address all of those. The payoff on that is more than just changing Horvath's epigenetic clock. The payoff is those last studies that you saw where we have total organ regeneration and incredible reduction in mortality risk.
Exactly. Well, it speaks to the upgrading of the system.
Yeah, it's my 57 Chevrolet being
That's
rebuilt.
Right. That's right. So I wanted to ask you a question, and if you know anything, if you have more insight into this, in one of the books that I've read about this, they describe, and when I read this, it stopped me in my tracks. Like I envisioned this most elegant process happening in the body, where they talk about epidolon finding its receptor, like we showed in that image much earlier with the pancreatin and the DNA. But when epidolon finds its receptors, it allows the DNA to unfold. Yes. And when the DNA unfolds, it now presents or makes available a receptor for another peptide. For example, I think in the example given in the book, it may have been the cartilage peptide, Cartilax. And so that now the cartilage peptide would attach to the DNA, and which may speak to a lot of it may speak to the science of combinations of peptides, where if we understand that epidolon is going to make the binding site more available for the cartilage peptide, we would automatically use those together. And if maybe we know that 2 peptides are competing for the same receptor, if that's even possible, we might avoid pairing those bioregulators. Is that
it's not possible. No, they don't. They never compete for the same receptors.
They're so specific. Okay.
Yes.
Yeah. Okay, that makes sense.
Yeah. You could take all 23. I mean, no one would need to do this. You could take all 23 of the natural peptides, and none of them would be competing against the other, because it's like salmon, going back to their spawning ground.
Yeah.
They go to their individual place that they need to go to.
Right. Oh, right. Because it's going to be at different binding sites. They're just, they have a natural affinity for whatever organ.
Yeah. You would never find, for instance, the cartilage receptors in the heart, and you would therefore never have a cartilage peptide going to the heart. Right.
But that makes total sense. But was it really interesting how they describe this process in this book? So I was trying to understand, because epidolon, you would think, has that affinity for the pineal gland. So what is epidolon doing in cartilage, or what is cartilage doing in the pineal gland? So it was just maybe it was just a theoretical example. I'll have to go back to it. I'll send it to you.
Okay.
Get all crossed up in this stuff. Okay, so a couple of very quick short fire questions, because we've been going a long time. We've taken up a lot of your time. So, and you've already said this, there's no interactions with medications when it comes to these bioregulator peptides.
None whatsoever.
Yeah, possibly the only thing people have to look out for is if they're on medication for a specific thing, aka thyroid medication. Keep an eye on whether or not you may need to talk to your doctor. If you were going to take matters into your own hands, definitely you want to keep an eye on how you're responding to your medication, because it may need to be changed as your body changes from the bioregulator.
Yes.
And then people ask as well about interactions with hormone therapy.
None whatsoever.
Right. We talked about stacking, which we talked about before. Last thing is, somebody in my group was asking about, or was speculating that people might be able to form autoantibodies to the animal bioregulators. And I deferred to you in that question. I said, I'm talking to Dr. Lawrence today, and he will answer that question. In the years that you've been working with the bioregulator peptides, have you ever seen somebody have an allergic or immune response to an animal bioregulator?
No, I haven't. And I've used, I don't know, 5,000 boxes of peptides or more. But thinking about it, you could actually have a person, if a person was specifically allergic to beef, basically to calf meat. I've never seen any study. Well, the Russians have done extensive studies in terms of safety and so forth, 30, 40 years ago. They've never had an issue with, but I would think theoretically, if a person had a strong allergic reaction to beef, I wonder if they wouldn't have.
I don't know that protein would be present, though.
I know. That's why I say it's theoretical. I've never heard of it. I would think no. The answer is probably no. But as a scientist, I have to keep my brain open to possibilities.
No, listen, like you, I've stopped saying no. Never. I've just said never seen it. There's always a first time. and maybe to shed some light on it, what this person would then used as his backup was that, well, he's seen somebody have a poor reaction to cerebrolysin. Well, my response to that is cerebrolysin isn't a bioregulator.
Right, it's a synthetic.
It's well, and even if it's not the biologic, it's extract of it's extracts of proteins and peptides from pigs' brains, I think. So it's a completely different compound, and it's way more than our 2 to 4 amino acid chains. Yeah,
and for instance, a good example is that with thyroid medication. Some people do really well on Armour, the natural, and they react badly to the Synthroid, the synthetic, and vice versa all the time. And so people will find that they can do well on one, but not on the other. Yeah. So who knows what? And I think, I would guess that the actual animal-derived bioregulator versus the synthetics, you're getting other cofactors with those amino acids that aren't present in the synthetic, which could explain why, they work the same but different. One is slower, longer acting. The other one is faster, shorter acting. So, Yes. And in our clinical studies, we only use, the natural peptides. At the clinic, they start people with the synthetic analogs for the naturals. But that's usually only a short time, maybe a couple of weeks or so, maybe a month at the most. Yeah. And then they go to the natural for the long-term treatment. Okay. Interesting. All right. Well, this, as just like last time, was incredibly enlightening. Thank you so much. Good. It's been my pleasure. Yeah. Well, it's been great. It's always a pleasure to connect with you. So I just want to thank you so much for your time and for sharing this information with people, because I think that for people to understand that there is not only light at the end of the tunnel, but there's now some skylights in the tunnel. What I want for everybody, I'm obsessed, of course, with my longevity, because I love waking up every day. I have this, my life has been like everyone else's, and that is, there have been difficulties and so forth. I had a professor long time ago. I can't remember if it was a law professor or medical or whatever. He said to a class of us, he said, he would rather have the worst day of his life than not. And it took me a moment. I remember thinking, Oh, I get that. Yeah, I'm with you. Yeah, I'll take the worst day of my life as long as I can have the day, because then there are going to be some really good days. And my life has been like everyone's. I've had challenges and so forth, but it's so exciting for me. I mean, it sounds like a cliche to be able to wake up every morning and have the gift of another day. And uh, oftentimes people will ask me, well, what are the interventions that are really good? And I talk about diet, exercise, but the one that's, I think, really important for me is just gratitude.
Mm-hmm.
Gratitude that I have the opportunity, as crazy as this world is these days, particularly,
No
the
kidding.
gratitude to be alive and to be going through the process of life, and the people that are in my life and what I'm doing, my work and other things. To have that is just incredible.
Yeah, that's very well said. And I think that's,
Even the yucky stuff sometimes.
yeah, it's having that overriding sense of purpose and gratitude, which we talk
Yeah.
about as being two of the most critical underpinnings of having a good life and of health, right?
Yep. Yep.
So
Okay.
thank you so much for that.
Yep.
And who knows, I think we'll do a part 3 someday, and maybe in a year talking about some new, or maybe less, whenever you
We'll
have.
see.
Yeah.
We'll see, Natalie.
All right. Well, thank you so much.
You bet.